Hakimi bin Roslan with metric number B0220202126. And the next one is Muhammad Zafi bin Muhammad Effendi with metric number B0220101155. And the third one is Afatin Liana Sakinah binti Muhammad Yatim with metric number B0220100024. And the fourth one is Muhammad Isma Arif bin Muhammad Judin with metric number B0220100051. And the last one, Anis Hanani binti Johari with metric number B0220100067. Our company name is Bekjaya and Co, a construction company, and we will present about 316 material. 316 material is second most common authentic stainless steel grade. Our technical crew will explain about 316 LSS in rolling process, in cool rolling and hot rolling. We also will show stress strain graph in our slide.
For the objective of this presentation is to elaborate the properties of normal 316L stainless steel and cold roll 316L stainless steel, and also how to enhance or to modify the mechanical properties of this 316L material. Problem statement. There's two types of stainless steel to be considered. The first one is normal 316L stainless steel, and second is cold roll 316L stainless steel. The disadvantages of these two materials is normal 316L stainless steel lack of tensile strength and yield strength compared to cold roll 316L stainless steel. And the disadvantages of cold roll 316L stainless steel is high force because of no heat applied, and the ductility will reduce.
The formula F over A was used to determine the stress, where F is the force and A is the cross-sectional area. Besides, we can use displacement over gauge length to get the strain. So as you can see in the slide, in the left side is the original graph for stress strain, original 316 LSS, and for the right is the graph of stress strain co-rolled 316 LSS. Tensile strength can be found by taking the maximum value in the stress. For original 316 LSS, the tensile strength value is 5.65 exponent 5. Meanwhile, for co-rolled 316 LSS is 9.84 exponent 5 Newton per meter squared. Yield strength can be determined by offset the value of 0.02 in the strain. As you can see in both graphs, it have a red line which is intercept to each other. Is the point where yield strength for both graphs. The yield strength for original 316 LSS is 2.6 exponent 5 Newton per meter squared. For co-rolled is 9.75 Newton per meter squared. The modulus of elasticity for original is 1.35 exponent 8 Newton per meter squared, and for modulus of elasticity for co-rolled is 1.89 exponent 8 Newton per meter squared. The ductility for 316 LSS is 221.2 exponent negative 3 meter, and the ductility for co-rolled is 19.6 exponent negative 3 meter.
Explaining about the relationship between microstructure and mechanical performance. Microstructure is basically the structure surface of a material that can only be seen by an optical microscope above 25 times magnification. Microstructure of a material will influence the physical and mechanical properties and can also be observed to analyze the defects of a material. And the act of heat treatment works to show the relationship between these two subjects, which are the cold rolling and hot rolling process. You can see the image for both processes, in which the microstructure of the material changed after its process. And from the graphs that are shown, we can see that the ductility and strength of the material also changed due to its transformation. With the cold rolling process causing the material to have a high strength with low ductility value, making it able to receive a high amount of force before breaking. And the hot rolling process having a low strength but high ductility value, making it able to be reshaped geometrically. In conclusion, both of these examples show the relationship between the microstructure and mechanical performance, with the microstructure of a material directly influences its mechanical performance.
Conclusion: the 316L stainless steel is good for KLCC because of its aesthetic appearance and good corrosion endurance. It also has good mechanical properties like high tensile strength and high yield strength. It's a good and a perfect steel for high building like KLCC.